Out my window, just west of Santa Fe, lies the near spiritual landscape of northern New Mexico. Barrancas, mesas, holy lands, the Rio Grande, home to the oldest civilization in North America. What stories we tell ourselves of origins and endings, of form and transformation, of gods, the word and law. All people at all times must have created myths and stories to sketch a picture of our place under the sun. Cro-Magnon man, whose paintings of animals seems to exhibit a respect and awe, let alone line and form, that equals or surpasses those of later millennia, must have spun answers to these questions. Who are we? Where did we come from? Why are we here? Did Neanderthal, Homo habilis, or Homo erectus ask? Around which fire in the past 3 million years of hominid evolution did these questions first arise? Who knows?
You know, 4 million years ago, in landscape not unlike this, in the Rift Valley in East Africa, our ancestors discovered what it was to be human. Somewhere in the last 4 million years, somebody, somewhere, began to wonder where we all come from. And I think it's true that for the past 4,000 years or 5,000 years in which we have something of recorded history, it's been clear that worldwide the search for the creation myth that would account for why we ought to exist in this vast universe has been created and recreated in varieties of forms around the world. My own ancestors on Sinai 3,000 years ago came forth with a story that's not too unlike the Big Bang today. But science, from Newton on, has cost us our paradise. Not sin, but science. Newton describes a world in which general laws give a clockwork universe that unfolds, and God is no longer needed immanent in the universe. He's needed to set up the laws and the universe in the first place and set it ticking. Salvation is not so easily had with a God who sets things up in the beginning but doesn't intervene thereafter. Then along comes Darwin, utterly shattering our image of life as the special creation of God, giving us this image of life evolving out of life, all of the branching rivers of speciation and extinction, propinquity and descent. Then comes Pasteur, the brilliant French chemist, microbiologist, who shatters the view that life can emerge spontaneously, as one can find maggots in rotting wood, by demonstrating that bacteria only give rise to bacteria, that bacteria don't form spontaneously in a complex chemical vat. Life only comes from life, Pasteur told us. Then why are we here? Where did we come from? Did life start on the Earth? Did life start somewhere else in the universe? Of course, nobody knows.
De nieuwste trend in de wetenschap is het onderzoek naar de oorzaak van de complexe wereld om ons heen. Hoe ontstaat uit de chaos van losse elementen de aarde, het leven, de maatschappij? Oeroude vragen die men nu te lijf gaat met computerprogramma's. De theoretici van het Santa Fe Institute in de Amerikaanse staat New Mexico zoeken naar de wetten van de complexiteit. Stuart Kaufman is één van hen. Hij is theoretisch bioloog. Zijn vraag is al 30 jaar lang: hoe kan uit de chemische elementen zoiets complex als het leven ontstaan?
Since Pasteur told us that life only came from life, most scientists have felt that the emergence of life, if it was to have happened on the Earth, would be an extremely improbable event. one of the things to ask is how soon after the Earth forms do we actually have signs of life? And the answer is astonishing. The Earth is something like 4 billion years old at most. Definitive signs of life are present in the rocks in terms of microfossils 3.45 billion years ago, and very clear chemical signs of life are visible at about 3.8 billion years. As if life started within something like 100 or 150 million years or less from the time that the planet cooled enough to support a solid surface and liquid water. If life started on Earth, it can't be impossibly hard. It happened too fast.
Kaufman denkt een antwoord gevonden te hebben op de vraag hoe het leven zo snel kon ontstaan. Wat gebeurt er als losse chemische elementen zich spontaan verbinden? Langzaam maar zeker ontstaan er steeds complexere verbindingen die elkaar gaan beïnvloeden. In den beginne was er het netwerk.
Most living systems are complex networks of chemical reaction pathways coupled together with the generation of actual structure. So if you think about the membrane of a cell, it's an actual physical structure. In fact, it's a low-energy structure. You can make the same thing by taking lipids in water and shaking them up, and you will make little hollow vesicles called liposomes that look an awful lot like cell membranes. They're bilipid layers. So life is an ongoing process of a marriage of low-energy stable structures with dynamical processes by which cells reproduce in vast networks. Then if you think of cells forming communities, such as microbial communities that covered this globe 3.5 billion years ago, one bacterium secretes chemicals that are food or poison to another bacterium, which must either eat or dodge or defend itself. In a complicated tactical and strategic game for life that's unfolded in vast webs of co-evolving, co-adapting, autonomous agents, molecular autonomous agents. The story of that co-evolutionary dance is, after all, not very different than the co-evolutionary dance of giant corporations today making goods and services, but needing to co-evolve with one another when the goods and services made by one organization change. Its complements, those that have matching goods and services, have to shift to match them. When the power of the automobile engine increases, the size of the tire and the banking of the roads have to change. When the car comes in, it displaces the horse, the carriage, the buggy whip, the saddlery, the pony express that used to ride through these very lands, but paves the way literally for paved roads, gasoline stations, traffic police, traffic courts, traffic cops, bribing traffic police and traffic courts, fast food restaurants, motels, restaurants in suburbia. Biological evolution at the molecular level, at the level of species that form vast webs of co-evolving critters making their livings with one another, and the technological society in which we live in which firms and technologies come and go in avalanches of speciation and extinction events on all size scales, all hint at the same general law of co-evolving networks of active agents making their worlds together.
Uit het een vloeit het ander voort. Zo ontstaat het netwerk. Blijft de vraag hoe het leven zelf ontstaat.
Maybe I can get this to all stick together. Is big.
Want wat hebben netwerken met het leven te maken?
So let's just begin to look at some simple reactions. For example, the molecule A could undergo a reaction to form B. And I will signify a reaction by a box representing the reaction and the line coming in and out. You should remember that reactions go in both directions. The arrow just picks out the product compared to the substrate.
Tussen de sterren wemelt het van de organische moleculen. Dat is bewezen wetenschap. Die organische moleculen zijn in grote hoeveelheden op de jonge aarde terechtgekomen en vormden zo de oersoe. Spontane chemische reacties leveren nieuwe producten, bijvoorbeeld stoffen die andere reacties versnellen, zogenaamde katalysatoren. Kaufman is ervan overtuigd dat het leven als een spontaan chemisch proces ontstaat. In de oersoep van organische bouwstenen organiseren de moleculen zich vanzelf in een netwerk van reacties. Reacties die elkaar in stand houden en versterken. Kaufman noemt dat een autokatalytische set.
An autocatalytic set would be a set of molecules, or is a set of molecules, having the property that all or most of the reactions by which the molecules are formed are catalyzed by one or another of the molecules in the system, except for the food molecules like sugar and amino acids that come in from the outside carrying matter and chemical energy with them. So a cell in your body is an example of a collectively autocatalytic set. There's no molecule in any cell in your body that actually copies itself directly. Every molecule in the cell that is not food has its formation catalyzed or sped up by some specific catalysts such that each molecule in each molecular species is catalyzed by some molecule in the system, and the system is, as a whole, a collectively autocatalytic set. So the version of the theory that I'm working on, the view of the origin of life that I have, is that for sufficiently complex chemical soups, the chances are extremely high that such systems will contain collectively autocatalytic sets in them. And if that view is right, of course, then it will turn out to be that the emergence of life is far more probable than we have thought in the universe, that it is not based on or restricted to template replicating DNA or RNA, and we will be able to try to build a much broader base biology based on very general principles about catalysis, work cycles, and organization and ecosystems than that's exemplified by the specific DNA, RNA bearing cells that now cover our globe.
For K3, we can calculate the critical biasing parameter value.
Oh, let's see. Let me make sure I understand that. Okay, so
Een oersoep waarin chemische elementen zichzelf onvermijdelijk combineren tot het leven. In theorie klinkt dat mooi, maar het gevaar van de chaos dreigt. Willekeurige stoffen combineren tot willekeurige nieuwe stoffen die elkaar beïnvloeden. Ze vormen weliswaar netwerken en gereguleerde systemen. Maar wat maakt dat dat op een ordelijke manier gebeurt en niet uiteindelijk verzandt in chaos?
And that's a curve that looks sort of like this, right?
Mm-hmm.
Okay, so order is up here, chaos is down here, and this is the edge of chaos. That's the phase transition.
Yes.
The question is whether or not behind the filigrees of historical accident and contingency and design and natural selection, there might nevertheless be some general laws. I hope so. I think that there's evidence, at least tentative evidence for such laws, and I think that all of the ideas that we're thinking about are completely testable. For example, if you think of a cell as a system in which molecules are activating and inhibiting enzyme activities and gene activities in time, and that's known to be true for real cells, such systems can behave in a chaotic way or in an ordered way. In a chaotic regime, if you change a little bit inside of the cell, if you put in a novel molecule, for example, or just change the concentration of some molecule a little bit by some chemical fluctuation, the system veers off into a completely different behavior than it would have done. Now, this is the direct analog of the famous butterfly effect in low-dimensional chaotic systems, in which the so-called butterfly in Rio changes the weather in Chicago. I like to joke that nothing will ever change the weather in Chicago, not the most heroic butterfly doing anything it wishes, not only in Chicago, or I mean, not only in Rio, but even in Chicago, except maybe fanning the local environment. In the ordered regime, if you perturb the system a little bit, it tends to flow along trajectories in a state space, a space of its possibilities, that reconverge on one another, so that the system shows what biologists call homeostasis. The idea is that there may be general laws that govern the behavior of cells, and perhaps communities of cells. If the behavior of the system were chaotic, and I'm a bacterium, and my behavior is chaotic because I'm embedded in it, it's likely to be lethal, because if I try to carry out an action that may be important for my life cycle, I'm likely to make a mistake because of some fluctuation. So chaotic regimes sound like a bad place to be. But deep in the ordered regime, the number of alternative behaviors that I can carry out is very restricted. So I don't have flexibility in my capacity to adapt or to carry out complex coordinated behaviors. One has the intuition, and it's still an intuition, that what cells will do, or communities of cells will do, is evolve somewhere near this phase transition between order and disorder. So far, the only evidence in favor of that is the evidence I just mentioned, saying that individual cells appear to be in the ordered regime somewhere near the edge of chaos. And then the hope would be that when you include the perturbations that come from other cells in a community that discombobulate each cell, that perhaps the community as a whole is very nearly poised on the order-chaos boundary. What should be stressed is that this is a hypothesis. I think it's a very attractive hypothesis. It might even turn out to be a law governing the behavior of isolated microbial communities. But it's still a hypothesis right now.
Uit computersimulaties blijkt dat als netwerken balanceren tussen orde en chaos, ze net als het leven zijn. Stabiel en toch flexibel.
I may completely screw this up.
Het leven als een zichzelf organiserend chemisch netwerk dat balanceert op de rand van orde en chaos. Het leven ontstaat spontaan. Het is een onvermijdelijk natuurverschijnsel.
It's a rather stunning image that if you have a sufficiently complex chemical soup, that life will swarm into existence more or less spontaneously in it. And I should hasten to say that this remains a theory. It's been proven on computer simulations, so it's true in silico, and there are mathematical theorems supporting it. There's no direct experimental evidence supporting this yet. Let's suppose that it works. Then we will be astonished until we see it as ordinary. When we see it as ordinary, that life can emerge from sufficiently complex soups, we will see ourselves as natural. And when we see ourselves as natural, rather than incredibly improbable, should that prove to be true, then we will see ourselves as the natural expression of nature herself, hence once again at home in the universe. Now there are those, of course, who want to view the origin of life as a providence of God, and I'm not particularly religious myself, but I myself feel comfortable with saying that if a creative universe unfolding in complexity and diversity on all scales, with galaxies and clusters of galaxies and clusters of galaxies, and great chunks of the universe moving with respect to other chunks, and non-equilibrium behavior all over, with free energy available to couple to complex chemistry all over. If the natural unfolding of such a system upward into bountiful complexity leads to life here and elsewhere in the universe, those laws are God enough for me.
Does it also mean that life must almost be abundant everywhere in the universe?
If the emergence of autocatalytic sets is a reasonably probable event, then on any planet or planetesimal, presumably that has something like liquid water and the capacity to create complex polymers and complex chemistry, it's at least plausible that life would start. Now, there's growing evidence for new planets found in distant stars or in the vicinity of distant stars. And we know that the giant molecular clouds and spiral galaxies are the birthplace of stars and themselves have very complex organic molecules. Each giant cloud has about a million solar masses. If there are billions of suns and billions of planets, and if the emergence of life is reasonably probable, then not only are we at home in the universe, but presumably a lot of other entities are as well. We'll find that we are not alone.
What would prove your theory right?
Well, in order to prove that there should be collectively autocatalytic sets of molecules, one actually has to make one experimentally. It's one thing to do computational experiments. It's one thing to even do fairly convincing computational experiments. But if it's right, somebody, somewhere, is going to have to make a self-reproducing collection of molecules in a test tube. Now, since everybody thinks that life is based on DNA and RNA, of course, the most exciting thing to find would be that it's possible to make self-reproducing systems out of something totally different, like proteins.
Een intrigerende theorie, maar het wachten is dus op een definitief bewijs. De avond voor ons laatste interview kreeg Kaufman een uitzonderlijk telefoontje. gevolgd door een fax.
So what's this?
This arrived last night by fax from some scientists at the Script Research Institute in La Jolla, and it's in Press and Nature.
And what does it tell us?
Title of the article is A Self-Replicating Peptide. These scientists have created, as far as I can tell, the world's first self-reproducing system of peptides. It's a single 32-long amino acid sequence that constructs itself from two subfragments linked 15 and 17.
It's sort of proof for your theory?
It's very beautiful work and the beginning steps towards proving the theory.
What does it do to you, this fax?
These results suggest something absolutely astonishing. They suggest that we are poised on the threshold of creating a broad new general science of biology. If we can create self-reproducing systems of molecules, and if we can do it de novo, out of proteins or DNA, RNA, and proteins, we will be able to build an understanding of what life is like and how it may emerge anywhere in the universe, not be hindered by the unique example that we live with here on Earth. At some point, you know, scientists who always say science doesn't know, but we're working on it, at some point we're entitled to say, wow, this is really marvelous news. It's possible, if this is confirmed and extended, that this result will be seen as important as the results of Watson and Crick in 1956 showing us the genetic code. Because in liberating us to have another view of how life may come about, these authors may be taking the first real experimental steps towards actually establishing our true creation myth.
The flash of the Big Bang 15 billion years ago has yielded a universe said to be expanding, perhaps never to fall together in a big crunch. It is a non-equilibrium universe. It is a universe of stunningly abundant free energy available for performing work. The life around us must somehow be the natural consequence of the coupling of that free energy to forms of matter. How? No one knows. But we shall hazard a hypothesis along the way. Here is no mere scientific search. Here is a mystical longing, a sacred core first sought around that small campfire sometime in the past 3 million years. This way lies the search for our roots. If we are, in ways we do not yet see, natural expressions of matter and energy coupled together in a non-equilibrium system, if life in its abundance were bound to arise, not as an incalculably improbable accident, but as an expected fulfillment of the natural order, then we truly are at home in the universe.